Voila! Can you find the similarity among the pictures? You have Hollywood rock, a normal rock, a can you smell what the rock is cooking rock, and a huge rock. Oh, you found it! Rocks! But what is lying beneath the external features of these rocks? Minerals! Indeed, minerals are inside the bodies of these rocks in the photos. Before we dive into our little informative video, let us have a look at the awe-inspiring quote by Philip K. Dick regarding minerals. That is the hardest job. Take a mineral rock from the dark silent earth, transform it into a shining light reflecting form from the sky. This correlates to us pursuing greatness. We take simple and almost undesirable things and convert them to wonderful and majestic creations, just like what we'll talk about today. Before we proceed, let us first term check the word mineral. So when we talk about mineral, we refer to a naturally occurring inorganic solid with a definite composition and is atomically arranged in repeating and systematic patterns. So that's the very meaning of a mineral. But what I really talk about today is regarding minerals found in an everyday object we can even put down, as it is pretty important in various aspects. So join me as we dive into an earthly look at the digital realm, an analysis of various minerals found in common smartphones, presented by yours truly, Gerald Magcalas. Let us first step back and honor the ones before us by taking a look back at brief information regarding the history of smartphones. So the very first mobile phones, which were never really phones, were just radio devices during the latter half of the 1940s, and these were used by the likes of taxi drivers and emergency services. Second, in April of 1973, Motorola successfully achieved mass production of handheld mobile phones. These phones are referred today as 0G phones in contrast to our 4G and 5G devices of today. Third, we have the 2008 invention of the T-Mobile G1, which was the very first Android phone, making it the OG of all Android phones. And finally, we're here in the current year, when 3.5 million people all around this majestic blue planet are having smartphones in their possession. And now, join me as we dive into the digital realm. We have here 4 columns corresponding to the 4 crucial parts of a smartphone: the phone's display, electronics and circuitry, battery, and speakers and vibrations. But spoiler alert, we will first have a look at a not-so part of a smartphone, but is a crucial external protective layer for us. So let's just have a brief look at minerals used in the production of phone cases. First, we have the mineral fluorite, which is a source of fluorine, as evident in its chemical formula, calcium fluoride. Fluorine has a wide range of uses, but in our digital realm, it is just an element used for phone cases. Number 2, halite. Halite, rock salt, or whatever you call it, is a mineral with the chemical formula of sodium chloride and is a source of sodium, which is primarily used for culinary purposes, but for our digital realm, salt is for phone cases. Next, rutile, a source of titanium, which is also a crucial element for most phone cases. The awesome thing about rutile is that it is fittingly named from Latin rutilus, which means red, and rutile, oh, I don't know about you, but it's pretty reddish. Second to the last mineral, crocoite, which is comprised of iron, oxygen, and chromium, the latter of which, just like the previous mentioned elements, is used for phone cases. And lastly, we have bromogerite, composed of silver and bromine. Bromogerite's bromine content is used in phone cases alongside other elements such as carbon, magnesium, and nickel. And now, we're here with the minerals used in our smartphone's display. Aww, isn't this familiar? Quartz. This is silicon ore, and silicon, when mixed with materials such as ceramic-based materials and potassium, creates a durable and long-lasting phone display. Silicon is also piezoelectric, which means when force is applied to it, electric charges will be released, just like how everyday stimuli cause our neurons to fire a biochemo-electrical signal to our nervous system. The same in reverse. When applied electric charges, vibration will be produced. So that's why it's used in our mobile phones. Learning something new? I hope so, because we still have a lot left to finish. Second, we have monazite. Monazite. Isn't that amazing? Monazite is rich in rare earth elements, or REEs. These REEs are pretty useful in the production of smartphones, especially in creating vivid colors in smartphone displays. Coming right up is cassiterite, a mineral with a high percentage of tin, which when combined with the element indium will form a very thin, transparent, and electrically conductive material used to make smartphone touchscreens. And what we call this mineral is indium tin oxide. Lastly, we have the mineral bauxite, an ore of both gallium and aluminum, which are very useful in the production of scratch-resistant phone screens and LED backlighting, which is basically a technology that can save amounts of mobile energy. Let's now dive into minerals related to various phones, electronics, and circuitry. First, we have chalcopyrite. Ooh, awesome name! Chalcopyrite! I want some pyre in my name. Get it? Pyre. Oh, anyway, chalcopyrite contains copper, a great conductor of both heat and electricity, which is ideal for the circuitry of most smartphones. And then we have wolframite, an ore of tungsten that has high stability and melting point, making it an ideal heat sink for the electrical connections inside of our mobile phones. Oh, what do we have here? We basically have a zinc, gallium, indium ore that is prevalent on both of our smartphones' display and silicon processors. Sphalerite! Next is tantalite, with its mineral commodity, tantalum. Tantalum is useful in manufacturing various shapes and sizes of phone capacitors due to its excellent volume to capacitance ratio. And here to make a comeback is our friend, quartz! Its mineral commodity, silicon, to simply put into perspective, is the basis of the very quote-unquote brain of our smartphones. And that's it! Let's now move on to the minerals used for the production of phone batteries. Coming number 1 on the list is spodumene, a lithium ore with a craving to create batteries of high power to weight ratio than most known phone batteries. We're obviously talking about lithium batteries. And then the cadmium ore, that is greenakite. Ooh, a superhero name. I wonder who named it. Green Lantern? Kermit the Frog? Your classmate? Just kidding. Just cheesy. Back to the business. So cadmium is usually paired with nickel to produce rechargeable batteries for our smartphones. Going swinging with number 3, manganite, an ore of manganese, which is, according to my research, is a promising technology for the reasons that I'll mention. Lithium manganese battery resources are abundant, are inexpensive, are non-toxic, and has high quality thermal stability. Next is the ever-popular graphite. Graphite is an ore of carbon and has the property of an ideal battery, as it is an electrical and thermal conductor. And for the last spin is the gorgeous cobaltian spinel. Its mineral commodity is, unsurprisingly, cobalt, which has 2 important battery ideal properties: thermal stability and high energy density. And also, batteries made from cobalt are fire resistant and can also manage more energy than your typical phone batteries. For minerals comprising our phones, speakers, and microphones, we have base, bass, astos. Basenacite and ore of various rare earth metals have magnetic properties useful for phone speakers, microphones, and vibration motors. Then we have another comeback in the form of wolframite. As we have mentioned earlier, this is a source of tungsten, which is useful as a phone, heatsink, and vibrating unit. On the third to the last spot is lanthanite, a neodymium ore useful for the production of magnets that are used for voice coil motors because of its powerfulness and autofocus mechanism. Sweet! Then we have the weirdly named borax, an ore of boron useful in the production of magnets using speakers, headphones, and vibration units. And for our last, let's get out of the world with the iron meteorite. This meteorite, as the name suggests, contains iron, which, with neodymium and boron, makes up various phone speakers, microphones, and vibration units. And there, we've survived those! Whew! But before I go, let's have a formal appreciation of my references. Thank you, and thank you. So, that's pretty much it. This is Gerald Macalas saying that let's enjoy a little bit of science on our little Earth. Let's soar the cosmos, everybody. Good day.
And I got this soda.